Welcome back. I think I have a formal introduction, but before that, I just wanted to point people in the right direction for George's talk tomorrow. It was mentioned briefly, but it's in Care Hall East, room 117. That's here on campus, and it's at 10 o'clock tomorrow morning, in case you're around and interested. And I gather you're going to be talking to us about a new hyper instrument that he's built called the vibraphone, and it involves the Connect system and pitch tracking. If there's something more you want to know about this instrument, go to the talk. 10 o'clock, Care Hall East, 117.
So we have 4 other very interesting talks. So it is my pleasure to introduce our next speaker, Professor Frank Russo. Frank received his PhD in psychology with specialization in brain behavior and cognitive science from Queen's University of Kingston in 2002. Then he completed a postdoctoral fellowship in music cognition with Bill Thompson at the University of Toronto, Mississauga. He also developed an interest in cognitive audiology during his postdoc. He's currently serving as the inaugural Ryerson Fellow at Massey College and as a visiting scientist at FONAC. Frank has nearly 20 years of experience in music perception and cognition research. He's currently the conference chair for the SMPC, Society for Music Perception and Cognition. He's been on the SMPC's board of directors since 2010. He received the Scholarly Research and Creative Award in 2010 and 2012 from Ryerson University for his outstanding achievement and impact. In 2011, he received an Early Researcher Award from the Ontario Minister of Research and Innovation and the Lecturer Research Innovation Award for Baby Buy from the International Textile and Apparel Association. Also, this year, he received the Early Career Award from the Canadian Society for Brain Behavior and Cognitive Science. He founded the Smart Lab, Science of Music, Auditory Research and Technology in 2006. The lab has become a leading hub of technology-oriented music cognition research in Canada with sponsorship from National Sciences and Engineering Research Council, as well as SHERP, Social Sciences and Humanities Research Council, and other agencies. Now, there's still several other things, but for that you'll have to go to Frank's CV. On a more personal note, if I could mention 2 or 3 things. I have the rare privilege of being Frank's first postdoc, and I'm very lucky that this is my first postdoc position. I honestly could not have asked for a better one. Now, as many academics here would understand this complex relationship between a postdoc and his or her supervisor, it's a lot more complex than being a graduate student and a supervisor. So when I first started, I thought, yeah, I have a PhD. Yeah. But beyond the PhD, okay, that's very, very cool. There's so much I have to learn, which, I mean, there's just no comparison. Right? So at another level, beyond being my supervisor, Frank has been an excellent mentor and friend as well to me. I remember one of my very first meetings with Frank when he said, "You're very thorough, you're very detail-oriented. You need to learn how to market your research." So that's when I realized the importance of not just working on a problem in your own little research island, but being able to collaborate with others so that you can enjoy the experience of pursuing the same kind of questions, asking the same things, and actually doing something really good that everybody can appreciate and enjoy, be it in academia or industry or wherever it is. And I've moved a long way since that meeting, thanks to my training under him. 2 things I really value. One is Frank's ability to look at multidisciplinary things with a broad perspective without getting caught in finer details. And his ability to encourage and nurture research ideas all the time, which is why the Smart Lab has been such a fertile environment for all of us. Despite the administrative pressures that come with an academic position, if you senior academics would know, I'm still amazed that he still displays this childlike enthusiasm whenever there's a new idea, and that can be so contagious and positive for an academic in training. So it is an absolute pleasure for me to introduce, to ask Professor Frank Russo to give his talk.
That's very, very generous. Glad I did not bet that anyway. All right, so I'm just back from a conference in Prince Edward Island, as I mentioned earlier, with George. And I thought it would be a good time now to share just a few travel photos before we get on to the business of the talk. And so this is the homestead of Lucy Maud Montgomery. She's the author of the Anne of Green Gables series. And I had never visited this before going to the island. And I've been to the island 2 times before. And had a look, it's lovely. And that's my wife and I on the beach on the south side, which are the warmest waters north of the Carolinas, I understand it from George. This is a lobster we ate later that night. This would be the longest bridge that has, this is the bridge that's built from New Brunswick to the island, which was quite controversial to build. And it happens to be the longest bridge ever built over any body of water that freezes. So it's quite challenging to build. It took 4 years. So I use this as a metaphor. Bridges are hard to build, especially when the 2 areas are very far apart. But it can be worth it because of the opportunities that they afford. So there are now things on the island that they didn't have before. There are some aspects of the cuisine that still require some road traffic, but there are things there that weren't there in the past. In this talk, I'm going to be discussing cognitively based music information retrieval as a bridge that's connecting 2 prominent growing subfields in music research. That's music cognition and music informatics. If you do some Google Scholar activity and compare different areas of music research, you'll see that these are real hotbeds. There's a lot of activity, a lot of momentum growing. There has been very little connective tissue, and I think what we're doing here is unique and important. So what I'll talk about is the potential to, this is quite presumptuous, but I think there's the potential to see a bit of a paradigm shift in music informatics. I'm not entirely sure. It's easier for me to see the impact of music cognition on music informatics than for me to see the impact of music informatics on music cognition. But maybe there's some potential for a paradigm shift there as well. Certainly, the use of computational methods is something that we could use more of in music cognition. So I'll talk about how music researchers can adopt a CogMIR approach and a little survey of the low-hanging fruit. So music cognition, I teach a course in this, if you're interested, but I'll tell you everything you need to know in one slide. We talk about making music, we talk about listening to music, and we talk about finding the music that we're interested in. So some topics that we've looked at in the lab include expressive music performance. So what constitutes an expressive music performance? What are the key elements? What signals, key changes? We could go on. What are the non-auditory correlates that are important in making music? Rhythmic synchronization. How does a performer come to synchronize with the other performers around them? And what level of latency, as George mentioned, is important? These are all fertile questions. Listening to music. This is really the core of music cognition, where it comes from, born out of psychoacoustics. This was the focus. And very much, again, I'm thinking back to George's talk, it's very much like the brain with a set of ears and no body. Those are its roots. So rhythm and meter perception, tonality perception, melodic similarity, expectation, what do we expect is going to happen next, given what's come already, emotional response and brain response. And then I'm using this term loosely, but finding music or memory. So what impacts short-term memory for music and long-term memory for music. So it's these same three broad categories that can be used to explain the breadth of work taking place in music informatics. And I have much less of a right to be summarizing music informatics, but making music generation, so there's generative music, adaptive music, so level of gameplay intensifies, so too should the music. Assisted music composition, this is something that I think you'll hear a little bit about from Wave DNA. Synthesizing music expression, so we had a little demonstration of that. There's much more work to be doing in that area. Musical accompaniment systems. Listening to music, so audio signal to score, visual representations of what it is that we're listening to that can augment our understanding of the music. And of course, finding music has been a very fertile area. So music search engines, social and economic issues, we'll be hearing some stuff from Matthew on that a little later, and music recommendation systems. All right, so what I'm trying to suggest is that there really is the structure in place for these two fields to be talking to one another. They're both concerned with making, listening to, and finding music. And then we have our question, if the future of music informatics, for the most part, it's been hard computing or machine learning, taking audio features to find useful pieces of music that match a query. That's kind of the classic way of thinking about the problem. Does cognition really have a role? Graphic. And our inspiration here, retrospectively, comes from Garrett Wiggins, who incidentally we had as a keynote at the inaugural meeting, the inaugural CogMIR meeting. He says that, yes, it does have an important role. We argue that it's time to reevaluate the MIR community's approach to building artificial systems which operate over music. We suggest that it is fundamentally problematic to view music simply as data representing audio signals. We propose a philosophical framework within which a scientific and or technological study of music can be carried out free from such artificial constructions. Ultimately, we argue that music, as opposed to sound, can be studied only in a context which explicitly allows for and is built on models of human perception. To do otherwise is not to study music at all. So here's someone who's very much in the thick of music informatics, who's arguing very strongly for a cognitive approach. It's not enough to just treat the music as a piece of information that the brain does not do something about. Okay, so approaches to model building. I'm going to contrast a music cognition approach to learning. There's many different problems that we could look at, but how do we learn a new piece of music? And then a music informatics approach. Rather, the problem I'm starting with is how do we hear similarity? So we can develop a computational model that is used to test or extend an existing theory. So a theorist comes up with some ideas about what sounds similar in music. We develop a computational model, and we assess whether this theory continues to hold water when we present it with different contexts. We see how well it generalizes. Maybe we knock out certain assumptions or certain components. So we get rid of short-term memory. We see what that does to our ability to hear similarity. These are the kinds of things that we might do with the model in music cognition. Okay. Typically, we're dealing with very rich, I would say it's very rich human data. There's very rich data all over the place that we're talking about today. Very rich audio data, very rich symbolic data. But here we have just a real richness of well-formed questions about how people think about music, and careful controls, and statistics to extract information about how people think about music. And I talked about this from the framework of subjective appraisals of music, but the same can be said of behavioral experiments that are run to look at how we process music, or physiological studies. The studies tend to be theory-driven. In contrast to the music informatics approach, I would say that it's typically weak human data for the model to work with. And when we talk about crowdsourced tags, there is something strong about that. You know, it's the opinion of tens of thousands of users that are saying that this sounds like something they say it sounds like. But it's hard to get at more nuanced questions, particularly questions about how a piece of music makes someone feel. Very good machine learning methods. They're at the forefront, I think, of music informatics. And we tend to be looking for efficient solutions, not necessarily ones that are aligned with human cognition, but obviously there are exceptions that we've already heard about. So what is a CogMIR approach? It's too early to say, because you've heard different perspectives on what CogMIR is. You know, in some cases it's cognition, it's ideas about embodied cognition, inspiring music technology. In some instances, it's the use of methods in order to develop new feature sets that can be used in complement with traditional feature sets. So this is really just one look at it. That's how I see it right now. The solution we're after should bear some resemblance to human cognition. The intent is to build more usable music technology. That's the end goal, I think, of CogMIR. We're building music technology. We're building search engines. We're building instruments, generative systems. But it's informed by how we think and feel in response to music. The computational models are constrained by theory, existing theory, and empirical findings regarding music cognition. We should give these models very rich input, the best input we could possibly give them, or output, however you want to look at this thing. So carefully controlled experiments, subjective behavioral or physiological data. These things should be context aware. So we do this in music cognition all the time, but we should be careful of a one-size-fits-all approach. So learning and acculturation shapes the way we listen to music. We know that. So that should be reflected in the kinds of experiments we run, the kind of data we collect that we use to develop our models. And in an ideal world, we'll have some theory-driven computational model that's slowly refined by empirical observation and successive iterations, improvements on machine learning. Okay, an example, emotional search. So this is obviously this is the question that we've been thinking a fair amount about in the lab. You're used to just suspending your disbelief. So with my photo collection earlier, so now you're not looking at my wife and I on the beach, you're looking at my grandfather's record collection, and you're looking at my record collection. We're talking about different scales here. And with this plethora of music, I have more, it's not necessarily easier. I can't just flip through and have something pop out at me. I might want to narrow my constraints a little bit. I might want to say, I want something that sounds like this, and I want something that makes me feel like that. So that's what we're thinking about in terms of emotion search. Okay, so about the tired subject to be music information retrieval, this semantic gap, but I have another layer that I'm going to add to that. There are levels of abstraction in music. So the auditory features we've been talking about are very low level. For the most part, you've heard about some mid-level features. And ultimately what we want to get at is some subjective appraisal. So that's heavy metal music. That's a piece of music that makes me feel angry. There's been talk for a very long time now about having to get to the ceiling, where there have been advances in ability to explain higher levels of abstraction, but not the level of abstraction we tend to use when we think about music and we talk about music in everyday conversations. And so, CogMIR is a framework that might facilitate closing that semantic gap. Okay, so this is just some pictures to flesh out this concept. We have music, we have low-level features, we have some subjective appraisal. Okay, and this is a very big distance here that we're trying to shore up. And this is the semantic gap that I've been talking about. It turns out, though, that there are many semantic gaps. And it's not necessarily the same feature set that's going to lead to the same subjective appraisals in all contexts. So this is connecting with the idea of context-aware systems and Lisa's talk that you heard about earlier, where you have different low-level features that are useful for predicting the same emotional mood states that are conveyed by pieces of music. So it's not just one semantic gap. In reality, there are multiple semantic gaps that need to be bridged. There's also a feature gap, unfortunately. So we know better, but we're kind of assuming for now that people hear the same low-level features in the same way, but they don't necessarily. So we've been doing quite a bit of work with Latin listeners. We started with a graduate student, going to Ecuador and playing syncopated and non-syncopated rhythms to Ecuadorian listeners, and looking at their ability to make fine rhythmic discriminations. And it seems that they're more sensitive, as you might expect, to these syncopated rhythms than our undergraduates here at Ryerson University. So we can have the same audio information that results in different characterizations of low-level features, I would say. And so we have this multiple semantic gaps, and we have multiple feature gaps. So this is a hard problem, and this is a problem we're looking at, I think, in CogMIR. How do we get started? I forget what I cooked up. Okay. On the music informatics side, I think it makes sense to start increasing the level of psychological validity in what we're feeding into these models. One way to do this is by doing experiments to get the data, or by collaborating with like-minded individuals. And obviously we have an example of that in the work happening at Dartmouth. So it's very challenging to master the methods of fMRI and machine learning in the same graduate career, but it can be done through the help of collaborators. On the music cognition side, we need to start building computational models that allow us to test, extend, and apply theories beyond what might be possible with lab-based experiments. It's useful to be able to build these models ourselves. These models can seed future experiments. So now I'm nodding to Naresh's presentation, where he started knocking out features, physiological features, to look at their impact on the subjective appraisal. So this is a level of explanation that we're not used to in music cognition. It's really a computational implementation of a theory, and it's something quite familiar on the music informatics side. So I think we just need to encourage more of this convergence. Plug. You're here today, which is excellent. So that's seeding your work in CogMIR. You should come here next year. We're going to do CogMIR again. We've already got a date, and we've already got a venue. It's not this room, because we're expecting big things, because we're piggybacking on a couple of other conferences that Mike and I are organizing, Society for Music Perception and Cognition, and that's August 8th through 11th. On August 7th, we'll have a pre-meeting satellite. There's some other post-meeting satellites. There's some auditory neuroscience meetings and some singing meetings. So there'll be a lot of folks here. It's a good opportunity to showcase this cognitive focus that at least we people in the room are into. All right, what's the low-lying fruit? I'm careful about this because I don't. There is no low-lying. but making music. So I think it's possible to have generative systems that are cognitively constrained. So the Liquid Loops team talked to you a little bit about constraining your compositional choices so that they are not only similar to a fragment of music that came before, rhythmically similar, but they also move in a particular emotional direction. So I think that's fairly powerful as a generative tool. Now, as to whether people will embrace it, use it, that's, who knows what the market will bring. But that's, I think we made some progress there, and this same approach could be tackled from many different perspectives. And we can see new tools in music generation. Listening to music, cognitive playback engines. Imagine cognitive playback engines where you're listening to a piece of music and the DAW or whatever it is you're working with, it has a window that is giving you voxel-based information or subjective emotions or something that is driven from a computational model. Maybe this is the most challenging one. It's the one that the your community is stuck on, the zombie that won't die. But genre-specific emotion is probably pretty challenging. But music networking, I think, is something that could be facilitated by a cognitive approach. So if you're dealing at least with symbolic music and something that lends itself quite easily to computation, although maybe I shouldn't limit it to that. If you can filter that music through models that convey something about the emotional properties of the music, then you have a new way of networking music makers. You have a new way of seeing relationships between music makers that maybe you didn't have before. Okay, so those are just some ideas. I'm sure there's many others, and that's all I have. So thanks to folks in the lab and our fine friends at WPNA. Any thoughts on the approach or questions? It's pretty high level. I don't know about questions, but thoughts, challenges.
I think another point of connection is the things like the system David Huron's been using, humdrum
Yeah.
things, sort of analysis, but in a different way, which is another sort of natural connection point where, especially music cog side, can get involved.
So, could you say more? Like, I see humdrum as a useful tool, and we have lots of music that's in the current format that can be searched, but
So, like, in a previous lifetime, when I was doing the analysis software, I wrote this package where you could feed in scores and look for patterns, and it was mostly for pitch class set manipulations, like for 20th century post-tonal theory stuff. And I was just very excited about the power you can have to basically find and empirically analyze, different. People talk a lot in the theory world about, this 1/4 pitch class set or this other thing, but what always sort of bothered me before I learned about music cognition is that you couldn't test it and show that this has been found more than other patterns. And so I think as a tool for something like a computational music theory, there's a lot of potential there.
Okay.
But then I sort of gave up and moved into the music cognition side. But this is all bringing back the past memories.
You're kind of talking about this other emerging field of empirical musicology, right?
Yeah,
You have a
with
hypothesis
that.
about how
Yeah.
music works. Well, let's test it by looking
Yeah.
at patterns of the way music is practiced.
Yeah, so it seems like it fits nicely with, you're talking about the building of different bridges, and that's one where I think there's a lot of built-up interest there, and, David's group is doing a lot of that. And everyone keeps prodding me to do more of that with doing all the manual extraction of cues.
Right.
So that would be an obvious.
Well, one real limiting factor in my mind is the current format. But maybe you put a bridge in front of it, like it's no longer.
Well, just there's, I think it's Music 2.1.
21.
Yeah, so that's kind of a next generation humdrum in Python and Castle, like reads music XML and MIDI and does a lot of stuff. And it's quite well written. And there's a bunch of younger musicologists that are more empirical and computationally savvy. I was interested, I think one thing that's, well, not missing, but it could be added to your bridging is, I think, musicians. The majority of cognitive science or cognitive studies have been undergrads fed pizza, or sometimes undergrads fed pizza that have music training or don't have music training, but it's always done in kind of a psychology study kind of environment. Rarely it will be like a musician playing an instrument, and I think that there's a lot of potential in interesting studies involving musicians actually playing their instruments and reacting to music or improvising with music. Unfortunately, playing an instrument in an fMRI machine is a little bit challenging, if not impossible.
But the biometrics we're dealing with, some of those can be you can pick up those peripheral measures on places other than the hands.
Yeah.
So you can get.
So I think that's a very, maybe not low-hanging fruit, but it would be very interesting to be hanging fruit.
Yeah. I think Gabe was over there has taste for that. We need to eat some of that fruit.
So let's take 5 minutes to grab coffee, and then we've got 3 half-an-hour talks starting at 3:45.